Hi everyone, welcome back to the channel. Today I would like to talk about the NumPy array creation. So there are 6 general mechanisms for creating arrays. First, conversion from other Python structure like list and tuples. Second is creating NumPy array uh, using the inbuilt function like range, ones, zero, etc. The third way is replicating, joining, and mutating existing arrays, means creating array from the subset of existing arrays. Fourth, reading array from the disk, either from standard or custom format. And fifth, creating arrays from the raw byte through the use of string or buffer. And the last one is use of by using the special library function like random. So you can use this method to create n-dimensional array or structure array. So first, let's start with the first option, that is converting Python sequence to NumPy array. So what I mean by that, let's first load the package. So NumPy array can be defined using Python sequence such as list and tuples. So list and tuple are defined using the bracket, the square bracket, and tuples with the normal brackets. So you can use a list of numbers to create a 1D array, and list of list will create 2D array, and further nested it will create higher dimension array. So in general, there are n dimension in NumPy. So to give example of first dimension, second, and three, we have this example. So this is going to create one dimension array, two and third. So let me run this, and let's first see the first dimension. This is we are using the list inside np.array, and it's creating the one dimensional array. Second, we are using the two dimension by passing the list within list. So there is first list, and within list this is the link. So this is the first row, second row, and these are the columns. And similarly, we have three dimension of arrays. So when you use numpy.array to define a new array, you should consider the d type also. So d type of the element in the array, so which can be specified as explicitly like in this example. So this feature give you more control over the underlying data structure and how the elements are handled in C and C++ function. So when value do not fit, you are using d type, so numpy can raise the error. So let's take an example here. So let's create the one dimension with integer 8. So it has given me an error because the integer 8 goes through minus 28, 128 to 127. And if you are assigning value greater than 127, it is throwing Python integer out of the bound of integer 8. So this feature can be so if you are performing calculation and there's a mismatch with the d type, you can unwanted result as well. So let's take another example. So here in this case, we are creating one dimension array A, B, and the unit is undefined integer 32. And then I'm just subtracting from A minus B, and let's print the result. And in the second example, I'm doing A minus B, but in this case, I'm converting into integer 32. So this will should give me different result, and this should give me minus 3. So let's see. So notice when you perform the operation with two array of the same data type, the resulting array is the same type, right? When you perform operation with different data type, NumPy will assign a new type that satisfy all the element involved in the computation. So here you unidentified integer 32, and in 32 can be represented as int 64. Let's move to the next intrinsic NumPy array creation function. So NumPy has over 40 built-in functions for creating arrays, and these functions can be split into roughly three categories. So based on the dimension, so we have 1D array creation function, 2 and 3. So let's see 1D. So in this, I'm using function arange, passing the argument 10 means it's greater 10, and because array start with 0, so it's 0 to 9. So NumPy.arange creates an array with regular incremental values. Check the documentation, for other examples, but the other examples are this. So we, in this case, have a start and the end, and I'm also passing the type as float. Next, I'm creating start end, but with the step also means it will give me the values from between 2 and 3, but the interval is minus dot 1. So dot 2 dot 1 dot 2 dot 3 to 9. We have a NumPy line space. We'll create the array with specified number of element and space equally between the specified beginning and the end value. For example, in this case, it's between 1 to 4, and the space between them is 6. So 1, 6, 2, 6 till 4. So advantage of this creation function is that you guarantee the number of element and start and end point. So in the previous, in the arrange, we have start and stop and step will not include the value of stop. Next is the 2D array creation function. So in the 2D array, we have a function called I. So I define the 2D identity matrix, and the element are where I equals to Z means row index equals to column index are equal. So let me create this. So I3 is means it's create identity matrix or 1, 2, 3. If you add this, so in the next example, it created 3 rows, 5 columns with diagonal, because diagonal will be this, where I for I the ith and jth index will be the same. So where they are same, its value will be 1. Next is NumPy diagonal dig can define either a square 2D array with a given value along with the diagonal, or given a 2D array returns 1D array, that's the only diagonal element. So the two array creation function can be helpful while doing the linear algebra. For example, let's run this. So it only created the value in the diagonal. Similarly for this. Next we have also so this was the 2D array, and we can convert this into using diagonal, and it will return what was the diagonal value of that particular array. Next, we have Vandermonde matrix as a 2D NumPy array. So each column of the Vandermonde matrix is decreasing power of the input 1D array or a list or tuple. So where the highest polynomial order is n minus 1. So this array creation routine is helpful in generating the linear least square models. For example, let's run this. And if let's create 2 columns, 4. So as you can see, this is each column here is the decreasing power of 1. Right? Power is getting decreasing by 1. So it is 2 raised to 3, 2 raised to 2, 2 raised to 1, 2, 0. Right, like this. Next, we have a general and the array creation function. So in this, we have 1, 0, and random. So let's go with NumPy 0. So this will create an array filled with 0 value with the specified shape. And the default type for D type in this one is float. That's why you will see the float as the output. So this create 3 raised to 2 and 3D array here, and similar 3 by 3 of 2 rows. Next we have ones. Ones, as you can see, if you instead of 0, you will have the ones. And next we have the random method. So this random method is the result of the default RNG, which will create array filled with random values between 0 and 1. And it is included with NumPy random library. So below two arrays are of, so this random seed is just to, you can replicate. So this is 2 by 3 and 2 by 3 by 2. And the last one in this section, we have NumPy indices. It will create a set of array stacked as one higher dimensional array. So one per dimension, which each representing variation in that. So if I run this, it will give me 0, 1, 2, 0, 1, 2. Next, let's discuss the replicating, joining or mutating existing array, means creating the array from within the array. So here I'm creating array A with 0 to 6, and we are going to print its value. Next, we are creating a next B variable by subsetting the array A from 0 and 1. Then we are going to update B, and let's see if the value of A is changed or it will remain same. So as you can see, the first we are printing normal value of A, then we are printing the value of B, then we are updating value of B plus 1, and it converted or added 1 here, 1 here, so 1, 2, and it also updated the A. So what I'm trying to highlight here is the address of A and B are same. So if it is not a copy, we are operating on the same array. If you want to create a copy, if you want to differentiate between A and B, then you have to create a copy of A using dot copy function like this. And in this case, all these same operation are happening here, but as you will see, A array will remain the same where the B values changes. So A array remain the same and the B values changes. Next, we have there are a number of functions available to join the existing. So block is that one. So we are creating this different type of identity matrix 0, diagonal 1, and we are just combining or joining those using block. So 3, 4 is the 4, 2 is two zeros, this one is 1, and this one is identity. Next is reading array from disk, either from the standard or custom format. So this is the most common case of large array creation. The details depend greatly on the format of the data on the disk, and you can read data using np load text. If let's say you have simple text txt file and there is some values separated by comma, so you can use that to load the value. And additionally, for fifth one is creating array from raw byte through the use of string or buffer. So there are a variety of approaches one can use. If the file has relatively simple format that one can write from simple input output binary and use NumPy from file function or to file method to read and write NumPy array directly from the file. And just to mention, use of special library function SciPy, Panda, and OpenCV. So NumPy is the fundamental library of array container in the Python scientific computing stack. So many Python libraries, like including the SciPy, Pandas, and OpenCV, use NumPy and dimensional array as the common format for data exchange. So these library can create, operate, and work on with the NumPy array. So this is what I had to discuss on uh, different types and the features related to the NumPy array creation. So we have gone through these 6 types to create the NumPy array. Hope you like this video. Thank you for your time.